Okay, so this particular graph is x approaching 0. Again, it's left, right, 0, and 0, f of 0 here. So as I approach 0, here's 0, and I'm thinking about the graph on both sides. Notice they're both just approaching the value. You don't see a point there, but because there's not an open circle, it's connected, and it's connected to this y value of 1. That means that all of these are 1. On both sides, it's approaching 1. The point there is at 1, even though there's not a point highlighted. That's what it's approaching. No holes or anything like that, so that one is 1. Okay, looking at this one, this is 2 from the left, 2 from the right, 2 and 2. Okay, so here's 2. On the left, we're looking at this part of the graph because it's the left side of 2 or left side of the asymptote. This one's going down, down, down towards the asymptote. That means that this is negative infinity. This one's going up, up, up towards the asymptote. That means this is infinity. And then that means that this is still does not exist or no solution because those two things are not the same. F of 2 does not exist because there's an asymptote, but also because there's not a point anywhere else. It's possible for there to be a point on the asymptote, and there isn't, so f of 2 does not exist. Okay, again, on this one, we are approaching 2 again. 2 from the left and 2 from the right. Notice they're both going down. We're going to say this is negative infinity. The limit is really not negative infinity. We're just saying it approaches negative infinity, but that's the process there. So again, these are the same. So again, this is approaching negative infinity. F of negative 2 is the y value. Notice there is a point. It's on the x-axis. This is 0. Okay, on this one, notice it says f of x approaches negative infinity and approaching positive infinity. This one's a little different because you do not look at the left and the right. You only look at the ends of the function. Because as I approach negative infinity, that means the x values are going this way. So I'm looking at the end of the graph trying to figure out what's going on. As I approach infinity, I'm going this way and I'm looking at the end of the graph. This end of the graph is going up, so it's infinity. This end of the graph is also going up, so it's also infinity. All right, looking at this graph, again, we're doing negative infinity and positive infinity. We're looking at just the ends right here. On this end, it's going up. This end is going down. This is negative infinity because it's the x values are getting smaller, so this is up, so it's infinity. Down is negative infinity. It's not always negative infinity and positive infinity. If there's horizontal asymptotes, it's approaching the horizontal asymptote. Notice this graph as I approach negative infinity, as I let my x values get smaller and smaller. This graph is approaching that asymptote of 4. And this graph on this side, as I approach positive infinity, as the x values get bigger, is approaching this asymptote of negative 2. Notice it's okay to have two different asymptotes there. And then this last question, thinking of like a sine or a cosine curve. Notice these two graphs are a little different. Because the graph, see how it's big and then it's getting smaller and smaller and smaller. This graph is going around the asymptote and it's getting smaller and smaller closer to it. Same thing's happening over here. So these two graphs are approaching those two asymptotes. This asymptote is 1. So as I approach negative infinity, this is approaching 1. As I approach positive infinity, it's approaching 0. Now, just so I can explain very quickly, if it were a sine or a cosine graph where the height does not change, and if I wanted to know the limit as x approaches infinity or negative infinity of that graph, the answer is does not exist because it just keeps going back and forth and the y value never changes. It's always 1 and negative 1. It never goes bigger or smaller. And so just in case you were wondering what would go on a regular sine and cosine graph, that limit does not exist as well.